Usually when we talk about enterprise software adoption, the numbers tend to creep up pretty slowly.
Yeah, it's usually a crawl, right?
Exactly. You get the early adopters, then the skeptics, and just this long, drawn-out rollout phase. But right now, looking at the 2025 Enterprise Guide from Acerlink, there's a statistic that, well, it absolutely stops you in your tracks.
It's a massive jump.
It really is.
At 3.
According to their data, a staggering 73% of enterprise organizations already have agentic AI projects in production, or at least in advanced pilot stages.
Wow.
Yeah, and that's up from just 34% like 18 months ago.
Yeah.
We're not talking about chatbots anymore. I mean, we're talking about autonomous digital coworkers.
Right. The speed of that adoption curve is just wild.
So to understand how we got here, we're doing a deep dive today into a stack of sources, including that 2025 AetherLink Enterprise Guide and some recent Forrester research. Our mission today is to figure out how companies are transitioning from using AI as a basic prompt and response tool to deploying entire autonomous digital workforces.
And doing it without breaking the law, which is the hard part.
Exactly, without ending up in legal trouble. Because
Yeah.
that's a real risk for businesses right now, especially in Europe.
Oh, absolutely. I mean, if you're listening to this and mapping out your own workflow for the year, you probably already know that the philosophical debate about whether artificial intelligence works well, that's over.
Yeah, that ship has sailed.
Completely. The entire conversation has shifted to how multiple AIs work together. And the impending enforcement of the EU AI Act stacked on top of existing GDPR frameworks, I mean, it changes everything for European businesses.
It's not just a nice to have anymore.
No, not at all. Building transparent, privacy-first, multi-agent systems isn't just some cool technological upgrade for a CTO to brag about at a conference. It is literally the baseline for surviving the 2025 compliance landscape.
Right.
If your AI can't explain exactly how it reached a decision, or if it exposes sensitive customer data across unchecked internal systems, you are in immediate legal peril.
Okay, so let's unpack this term agentic AI, because it's easy to hear that and just think we're talking about like a slightly smarter chatbot that remembers your name.
Yeah, a lot of people make that mistake.
But the fundamental shift here is from tools to teammates. It's a difference between reactive and agentic. Think of it this way. Reactive AI is like a microwave.
Okay, a microwave.
Yeah, you put your prompt in, you push a button, and you get a single predictable result out. It's incredibly useful, but it only does exactly what you tell it to do in that exact moment.
Right, it's totally dependent on you.
Exactly. Agentic AI, on the other hand, is like hiring a personal chef. You don't give a chef a step-by-step prompt on how to boil water or, chop an onion. You give them an objective.
You just tell them the goal.
Right. You say, I'm hungry for Italian, and we have a gluten allergy. And then the chef autonomously checks the fridge, realizes you're out of tomatoes, plans a new menu based on what's available, cooks the meal, and cleans up.
That is a great analogy. They adapt to the environment and the constraints without you holding their hand.
Exactly.
And that shift from feeding a machine prompts to assigning it objectives, that really explains why 82% of enterprise users are now demanding persistent AI.
Persistent meaning it stays active.
Yeah, exactly. When you use a microwave, you have to stand there in the kitchen. When you hire a personal chef, you leave the house and go get other work done. Under the hood, this means the AI is maintaining state.
Okay, maintaining state.
Right. It's keeping a running memory of its subtasks over hours, days, or even weeks. We're moving from seeing AI as a productivity tool, like a fancy calculator, to treating it as actual infrastructure for workflow execution.
Wow.
You aren't speeding up a task, you're offloading the execution of the task entirely.
But wait, if we stick with that kitchen analogy for a second, what happens when you scale that up?
What do you mean?
Like, if you don't just have one personal chef, but you've hired a pastry chef, a sous chef, a prep cook, and a sommelier, and they're all running around the exact same kitchen.
Hey.
Right. If the pastry chef and the prep cook both need the oven at 400 degrees at the exact same time, who wins? Without a head chef, the kitchen just shuts down or burns down.
Yeah, and that's actually the core engineering challenge of 2025, and solving it requires something called the control plane.
The control plane.
Right. If you deploy specialized agents across a company, you need an intelligent routing and governance layer. It acts like air traffic control for your AI.
Oh, interesting. So it manages the flow.
Exactly. The control plane handles agent allocation. It looks at an incoming task, parses the intent, and decides whether the compliance agent needs to review it or maybe the marketing agent.
Okay, that makes sense.
And it manages dependencies, ensuring that the documentation agent doesn't start drafting a report until the data gathering agent has actually finished pulling the analytics. And to address your oven analogy,
Yeah, the fighting over the oven.
it handles conflict resolution. If two agents propose competing actions or fight over computational resources, the control plane mediates that based on the organization's overarching business rules.
So if I'm a developer listening to this
hmm
and my CTO just walked in and said, build us a control plane, how do I actually do that?
Well, it's not easy.
Am I just sitting down and writing a really, really clever master prompt? Like, you are the manager AI. Please make sure the other AIs play nice.
No, absolutely not. You definitely cannot prompt your way into enterprise-grade reliability. That is probably the biggest misconception slowing down enterprise rollouts right now.
Really? So prompts aren't enough.
Not even close. This relies heavily on structured software development kits or SDKs, like those built by EtherDev. To understand how a multi-agent system actually functions without hallucinating all over the place, we have to separate two pieces of underlying architecture:
Okay, what are they?
MCP servers and custom agent SDKs.
What's the mechanical difference between those two? Because they sound pretty technical.
Yeah, it's actually straightforward once you break it down. An MCP, or Model Context Protocol server, is just the bridge. It exposes an API that connects your AI model to your external data sources, like your secure SQL databases or internal wikis.
So it's just a connection.
Exactly. It just gives the AI eyes to see the data. But the custom agent SDK, that is the actual brain and the guardrails of the operation, the SDK handles the memory, logging every state change so the agent remembers what happened yesterday. And crucially, it handles retry logic.
Wait, how does that retry logic actually play out in real time? Like, give me an example.
Okay, imagine your financial agent hits an external API to pull current interest rates, but the API is down or maybe rate limited.
Happens all the time.
Right. A basic prompted AI will either crash the whole workflow right there, or worse, it'll hallucinate a fake interest rate just to finish the task.
Oh, yikes.
Yeah, disaster. But a robust SDK steps in, intercepts the error, and initiates an exponential backoff. It tells the agent, wait 2 seconds, try again. If it fails, wait 4 seconds, try again.
And it's doing this all on its own.
Yep, it does all of this quietly in the background without user intervention. And here's a reality check that developers are discovering: the actual agent logic, like the smart part of the language model,
Yeah.
that's only about 10% of the work.
10%. Wait, really? I would assume the AI model itself is the bulk of the engineering effort.
That's what everyone thinks. But the SDK and the orchestration framework make up 60 to 70% of the total development effort. That boring infrastructure delivers 90% of the operational reliability.
Okay, I think I've got a better way to look at this than the personal chef thing.
Let's hear it.
The AI model itself is like raw electricity. It's powerful, it makes things happen. But the SDK is the wiring, the copper tubes, the fuses, and the circuit breakers in your house.
Oh, that's good.
Because you don't just pump raw electricity into your drywall and hope it turns on a light bulb. You need the infrastructure to route the power safely, and the circuit breakers, the retry logic, to stop it from burning the house down when there's a power surge.
That is exactly how enterprise engineering teams are viewing it today. They are spending most of their budget on the circuit breakers.
Let me challenge the end goal here, though.
Okay, go for it.
With all this complex orchestration, the wiring, these multiple specialized agents talking to each other, passing data back and forth, managing their own dependencies,
Yep.
it sounds like humans are just being systematically engineered out of the process.
It does sound like that, doesn't it?
Yeah. Are we just building autonomous companies that run themselves entirely in the cloud?
The data actually tells a completely different story. The implementation strategy for top-tier companies completely flips that fear on its head.
Because looking at the research here, specifically a 2024 study from Forrester, there's a finding that seems almost counterintuitive if you just assume AI is about replacing jobs.
Right.
They found that using AI to augment and amplify human expertise delivers a 3.2 times greater return on investment than trying to fully automate a process from end to end.
Yeah, a 3.2 times greater ROI is a massive signal. It proves that full automation is often a trap.
A trap.
Yeah, and if we look at the division of labor in these successful companies, it explains why. Agents and humans just have entirely different bottlenecks. We let each side do what they are mechanically best at.
Okay, so what are agents best at?
Agents are built for massive information synthesis. They can aggregate unstructured data from 50 different PDFs and databases in seconds, recognize hidden quantitative patterns, and, do it at 3 in the morning without complaining.
Right, but they lack the human touch.
Exactly. They completely lack real-world context and empathy. Humans are terrible at reading 50 spreadsheets in a minute, but we are exceptional at judgment calls, understanding political nuance, maintaining organizational values, and managing stakeholder relationships.
So in a multi-agent system, the human doesn't do the execution, the human becomes the approver. The agents do the heavy legwork, gather the evidence, formulate the options, and present a synthesized recommendation. And then the human reviews it, applies context, and makes the final call.
That's the workflow.
It's like having an army of tireless interns prepping your executive briefings.
Yeah.
You wouldn't let the intern sign the multi-million-dollar vendor contract, of course?
Obviously not.
But you absolutely want them to read the 500 pages of terms and conditions to highlight the legal risks for you before you sign.
The intern analogy works perfectly because it highlights the oversight required. And keeping humans in the loop like this, where an agent aggregates massive amounts of data and presents it to a human decision maker, well, that brings us straight into the biggest hurdle for European enterprises right now.
Oh, the compliance piece.
Yeah. The moment your agents start scraping and synthesizing data across departments, you trigger a massive web of regulatory requirements.
The EU AI Act. It's basically the elephant in the room for every CTO in Europe.
Exactly. The Act mandates strict transparency, undeniable audit trails, and extreme data minimization for any high-risk system.
So you can't just plug a massive language model into your customer database and let it read everything to answer a simple query anymore.
No, absolutely not. That's illegal now. Sophisticated enterprises are tackling this by implementing privacy-first architectures right from the ground up. And this involves 3 major mechanisms: on-device processing, federated learning, and tokenization.
Okay, let's break those down mechanically, because federated learning sounds like great marketing jargon, but what is it actually doing?
So normally, to make an AI smarter, you pull all your user data from various branches into one massive central cloud, like a giant data lake, and you train the model there.
Right, big data.
But that central honeypot is a massive security and compliance risk. Federated learning hides the direction. Instead of bringing the data to the model, you send the model down to the local servers.
Oh, interesting. So the data stays put.
Exactly. The agent sits on the local device, learns from the data there, and then only sends the lessons like the mathematical weight updates back to the central server. The raw data never leaves the local environment.
So the central brain gets smarter without ever actually seeing the local data. That makes total sense. What about tokenization?
Tokenization intercepts data before the language model's logic processing even kicks in.
Okay, how does that work?
Imagine your agent is tasked with reviewing a mortgage application. Before the AI's brain even sees John Doe's name, address, and salary, the tokenization layer strips out John Doe and replaces it with user 489.
Ah, so it anonymizes it instantly.
Right. The AI analyzes the financial math, approves user 489, and then the secure side of the system swaps the real name back in on the output. The AI literally never knew who it was evaluating.
Wait, I have to jump in here and push back on this.
Sure.
Because as someone who follows tech infrastructure, the moment you say on-device processing, decentralized federated learning, and heavy tokenization layers, I immediately think about latency.
It's a fair point.
Right. 12% at an enterprise scale of millions of transactions a day is massive. How are companies justifying that computational drag? Doesn't adding all of this privacy filtering completely throttle the system's performance, making the AI compliant but incredibly slow?
It is a completely valid engineering concern, yes. Organizations are reporting a 5 to 12% performance overhead when implementing these architectures.
That's pretty significant.
It is, but you have to look at where that latency is happening versus where the velocity is gained. Yes, the compute time for a single API call might take 12% longer because it has to pass through a tokenization layer, but the overall workflow velocity increases by days or weeks.
Because you aren't waiting on a human.
Exactly. A 12% compute delay, which is measured in milliseconds, is absolutely nothing when that system eliminates a 3-week legal compliance review bottleneck.
Okay, that clarifies it. You're trading milliseconds of compute for weeks of human waiting time.
Plus, that modest compute overhead is a very small price to pay for the ultimate competitive advantage. When you can guarantee regulatory confidence, and when you can look your clients in the eye and mathematically prove their data is structurally protected from AI ingestion, you win their trust.
And trust is everything right now.
In a market flooded with careless AI deployments, trust is the ultimate currency.
To really drive this home, I want to walk through a massive real-world use case that AetherLink detailed because it shows exactly what this multi-agent workflow looks like in practice.
Yeah, this case study is phenomenal.
Imagine a European financial services firm. We're talking 800 plus employees,
Yeah.
and they're absolutely drowning in compliance. MiFID II, GDPR, anti-money laundering
So
regulations.
much red tape.
So much. It was taking their human compliance team 5 to 7 days just to do routine transaction reviews. Compiling a single monthly audit trail was sucking up 40 hours of manual labor.
It's a classic enterprise nightmare. High stakes, massive volume, entirely manual data gathering.
So they deployed what we've been talking about, a multi-agent orchestration system, a digital coworker squad. They didn't just buy a shiny chatbot. They deployed 4 highly specific, specialized agents.
Right.
First, a regulatory monitor agent. Its only job is to watch the regulatory bodies, read new rules, and translate what they mean for the firm. Second, a transaction analyzer agent. It reviews actual customer transactions against those updated rules and flags anomalies.
Working together.
Exactly. Third, a documentation agent, which takes those flag transactions and automatically builds the audit trails and evidence packages. And finally, a policy orchestrator agent, which acts as the manager, maintaining firm policies and escalating the really weird edge cases up to the human leadership.
Notice how the mechanics of that map perfectly to the control plane concept we discussed earlier.
Oh, right, the air traffic control.
Exactly. It's all about how they pass the baton. The regulatory monitor agent reads a new EU directive. The control plane instantly writes that newly translated parameter to the transaction analyzer agent, which immediately changes its filtering behavior.
That is so cool.
And when it finds a flag based on the new rule, the control plane routes the raw data to the documentation agent. They're talking to each other, maintaining state, without a human having to copy-paste data from a regulatory PDF into a transaction monitoring software.
And the metrics on this implementation are just stunning. Those compliance reviews that used to take 5 to 7 days dropped to 24 hours.
Incredible.
That monthly 40-hour nightmare of prepping an audit trail plummeted to just 8 hours. But here's the most important part, tying back to that 3.2 times ROI and human augmentation we talked about earlier.
Right, they didn't fire anyone.
Exactly. By deploying these agents, they didn't fire the compliance team. They freed them. Instead of drowning in paperwork and manual data entry across 3 different software suites, the human experts could finally focus on strategic risk assessment and complex vendor management.
That's huge.
Overall, top-performing enterprises using these strategies are seeing 35 to 50% efficiency gains in just 6 months.
That is the tangible power of the digital coworker model. You elevate the human worker from a brute force data processor to a strategic decision maker. You let the circuit breakers handle the surges, and you let the humans pilot the ship.
So looking at all of this from the AetherLink research, the shift in architecture, the regulatory demands, and the case studies, it's time to distill this down. For me, my number one takeaway from this entire deep dive is that fundamental reframing we talked about at the start.
Tools to teammates.
Exactly. We have to stop thinking of AI as a software tool that we use and start treating it as a digital coworker that we collaborate with. And the best part is, you don't have to do it all overnight.
No, definitely not.
The guide outlines a really clear 4-phase implementation roadmap. You don't build 4 agents on day 1. You start phase 1 with just a single pilot process in the first few months. You build that baseline SDK infrastructure, you prove the value to stakeholders, and then you scale up to complex multi-agent orchestration. It takes this incredibly intimidating, heavy concept and makes it feel highly accessible.
I completely agree. For my number one takeaway, it's the realization that the competitive landscape has fundamentally changed.
How so?
The organization with the biggest, flashiest, or most expensive underlying AI language model isn't going to win the market in 2025.
Oh, interesting.
The winner is going to be the organization with the best orchestration and control plane strategy. It's all about how you manage the agents, how you implement retry logic, how you guarantee privacy through tokenization, and how you enable seamless teamwork. Execution and governance are now far more valuable than raw processing power.
That's a huge paradigm shift, execution over raw power.
And if you're listening to this and mapping out your strategy, this raises an important, perhaps slightly provocative question to chew on as you design these systems.
They lay it on us.
We are currently focused on building autonomous agents that can seamlessly communicate with each other inside a single company, protected by internal firewalls, right?
Right.
But what happens in the very near future when your enterprise's procurement agent starts directly negotiating with a vendor's sales agent? Are our current business protocols and legal frameworks ready for an economy where artificial intelligences do the negotiating behind the scenes at machine speed, completely outside of human oversight?
Two AIs haggling over a supply chain contract in milliseconds while we sleep.
The heck?
That is both incredible and slightly terrifying to think about.
It really is.
It brings us right back to that personal chef metaphor. We aren't just trusting them to cook the meal in our kitchen anymore. We're about to trust them to go to the farmer's market and aggressively haggle over the price of tomatoes with the farmer's AI.
It's a whole new world of workflow.
It really is. For more AI insights, visit AetherLink.ai.